Hello friends, welcome back to my YouTube channel. Today we are going to discuss about the Spark optimization technique, and using this technique we can handle easily petabytes of data, like big companies using this technique, and by using that they are able to managing the data warehouse. The company which using 10 petabytes 100 petabytes of data in a day, so they need the techniques to optimize. So we can see all the techniques how to optimize the data warehouse, how to optimize the data pipeline using this Spark optimization technique. So let's start the video. So first we come to the topics which we are covering here: shuffle partition, broadcast join, sort merge join, bucket join, dynamic partitioning, pruning, adaptive query executions. So before that, the most important thing is shuffling, and everyone listen about this word shuffling, how it is work in Spark, and yeah, we can say PySpark. So shuffling refer to the redistributions of data between partitions. It happens when an operation requires data to be rearranged, moving data across the cluster, so related data end up in the same partition. So why it is happening? Actually, when we are using the group by clause, order by clause, joining the tables, so shuffle happened. It means the data distributed across the partitions, and when the data distributed across the partition, it is the network speed, input output, and also the processing power of the CPU. So it is expensive operations, and due to the shuffling, our performance have issue, and the query becomes slow, and which have lot of group by aggregations, and there is a shuffling happens, so it make the query slow. So the performance optimization, basically how we can stop the shuffling and how we can control the shuffle operations. So now come to the shuffle partitions. So what's the shuffle partition? So when we write the query, when we write the simple code, so the data is distributed across the cluster, and you can say across the node into the partitions. So splitting data into partition ensure that tasks can execute in parallel across the cluster. So whatever data we have, that is partition across the nodes, and we have the node which using the core of our system. So suppose we have the 4 core octal core system, and that core further divided into the executor. So every executor have some cores, and we can say executor something like working node. So that working node execute the task in parallel. Why? Because there is a partitions of the data, and that all partition working together and parallel across the cluster. So job involving shuffling like wide transformation, like group by, join, order by, and aggregated operations. So where the any kind of like this group buys and operations, so where is shuffling happens, the data move to the partitions. So suppose we are joining the two tables on based on the key, so same keys data, same common keys data of the partitions get together into the same kind of data get together into the one partition, so that join can do. So start with the value at least equal to the number of CPU cores into the cluster. So the shuffle partition, we can give the value. Normally we can give the value which is equal to the number of CPU cores. Suppose 8 core CPU. So we can give the value 8. So 8 partitions, 8 cores means 8 partitions distributed into the 8 cores, and they work parallelly. And we can increase the shuffle partition according to our need. By default shuffle partition value is 200, and you can see the variable here. This variable value we can adjust according to our need, but shuffle partition also have the issue, basically shuffle partition we are using to increase the parallel transformation, increase the parallel increase the parallel processing of the data. So we are using the shuffle partition so that our cluster is our code distribute the data parallelly, and query become fast. But there is a certain disadvantage also when we are increasing the number of partitions. So data skewness also increases. Data skewness means might be there is a case in some partition data is large and in some partition data is low. So due to that, the partition which have data large, so when query scan that partition take time. So unequal distribution of the data across the partition, that is the drawback of this, and that's reduce the query performance, that reduce the result output, that delay the output. So data skewness is the major problem in the shuffle partition. So if we are increasing the number of shuffle partitions, so it's automatically increase the parallelism, and but there is a possibility of the data skewness. So let's move forward how to overcome these things. So there is a broadcast join which majorly used by the company to overcome the performance issue. So what is that broadcast join? So broadcast join is used when one of the table is significantly smaller than the other, and the smaller table is broadcasted to all the node in the cluster, and join operation is performed locally on each node. So why we are using the broadcast join? So suppose if we have the two tables, one table of 10 GB and second table of size 100 GB, so we can easily make the 10 GB table which is small as compared to 100 GB, we can make them broadcast that table. So that table is distributed across all the nodes, so that copy you can say local copy created across all the node. So it is expensive, but it is also make the query very fast. So when performing join, one of the data set is small enough to fit in the memory, so we are using the broadcast join. So it reduces the shuffling network, making join more efficient by enabling local join operations. So our join become fast. Why it is fast? Because earlier the data shuffle, when we are using the shuffle join, so data shuffle across the cluster and across the partition, same data comes together into the node. So that kind of shuffling is stopped because every data copy is distributed across all the nodes. So all the node have the same copy. So if there is a join happening, so there is no required of the shuffling. But yeah, it is expensive because it uses all the memory, all the RAM of your system. Now we can see the example of how to apply the broadcast join. So this is a simple example of PySpark. You can see maximum size of data frame to be broadcasted default 10 MB. So if one of the table size is 10 MB, so Spark automatically detect the broadcast join in that case. But suppose we have the large table, so we manually do the broadcast. So how we can do manually, because we know our data very well, and sometimes we need to change the Spark optimization technique, and so that our join become fast. So we can see here we create the first data frame, and here we create the second data frame, and you can see we just join the data frame, and this is the smaller data frame dimension df. So here is, you can see very less record. So I just want to show how to broadcast the data frame. But in the practical scenario, when we have the GBs of data, so we are doing the same way, and this is just an example. So I am doing this data frame broadcast, and we are joining two data frame based on the ID, and then I display the record. So it make the query fast, it make the output display fast. Why? Because we make the small table as a broadcast join. So I hope you understand this, the concept of broadcast join. Now come to the sort merge join, and this is also the kind of join method which apply by the Spark by default. So suppose we have the large table, and in case of large table, Spark use the sort merge join. So that is the default applied by the Spark, and it used when both data frames are large. Shuffling is unavoidable. Here shuffling happens, so you can't avoid the shuffling. But yeah, it is used when your data frame is very large. Spark will automatically use sort merge join. So here you can see I created the data frame, and this is something 10 million, and based on I just sort here also, and I created this is 1 million, and I created one more data frame like 500,000 to 1.5 million, and I created converted to the data frame and then sort based on the ID, and I join these two data frames, so it apply the sort merge join. So what it did, it do the shuffling, then sorting, and then merging these two data frames. So this is normally Spark applied in all large data set, and if we feel like in our data set one of the data set it is small as compared to others, so we can go for broadcast join. Now come to the bucket join. So bucket join is an efficient way to join large data set by using bucket to partition the data. Each table is divided into fixed number of buckets based on a hash of the join key. Each bucket contains rows that share the same hash value for the join key. So bucket join is something like where we are joining large data set and we want to partition the data and then bucketing the data. So what bucket join do? What the bucketing what the concept of bucketing? So bucketing actually when we apply the bucket, so it divides the data into the fixed number of files, and we can say fixed number of bucket based on the hash of the join key. So whatever the join column, so it create the hash value of that, and based on that join key it divide the fixed number of bucket. So we can say when we are saying fixed number of bucket, it means it create the certain files which have record distributed equally and on the sorted way. So it make the query fast, and let's see the example. So you can see this data one, and we created here two records and data two. This is the second data frame. I created two data frame, and when we create a data frame, first we need to write the data frame into the Parquet format. So again Parquet format is must use into the our bucket, and so Parquet format is a column storage format which is largely used, and it compress the file, and it is a fast as compared to other format. It take less space, and also query become fast on that format. So here I am using the Parquet format, and bucketed by, that is the important part which I want to explain you. So here I am creating the 8 bucket based on the ID column. So it create the 8 files with the equally distribution of this column of ID, and then again I use the sort by operation. Then I write this file on the table, we can say some bucket or some directory folder. So we store the data frame in the form of the bucket, and bucket we can say in the form of equally distributed file in which data is distributed based on the ID. So and again I created the second data frame here, and you can see the format here. I again pass the ID here. So this two data frame is sorted and based on the ID column, and here 8 files created based on the hash value of this ID column. So now second thing is we need to join these two bucketed file. So when we join the two bucketed files, so we need to read this two bucketed table where it is stored. So might be in the S3 or some other location, and by reading this bucket I created the data frame and then apply the join on this two data frames. So that the concept of bucket join. So it make the query fast. Why it is fast? Because when we are joining this two data frame, so that bucket actually already here the file is distributed according to the particular join column ID and on the sorted way. So it make the query fast, it make the join fast. So I hope you understand the bucket join. Now come to the dynamic partition pruning, and it is also something very important. So dynamic partition pruning optimize query performance by reducing the number of partition scanned based on runtime, and dynamic partition pruning when filter value at runtime. So it is something like when we have the large number of partition and we have also the filter criteria. So before scanning the partition, the dynamic partition pruning apply the filter on that partition at runtime, so that it reduce the number of partition which we need to scan. So that make the query performance fast. And how can we do enable? So here you can see dynamic partition pruning enabled. This is the configuration variable which we can make here true. So suppose I give you the example, this is the select query, and there is a two table sales data and region info, and region equal to region, and I am apply region type equal to North America. So this is the filter, right? This is the filter, and this is our partition key, as region is partition key. So this is partition key, and this is the our filter, right? So what when this join applied, and it applied on the partition key. So what in the backend PySpark do, it scan all the partition, right, before applying the region type filter. So when we do dynamic partition pruning enabled equal to true, so what it did in backend, so before scanning all the partition, it applied this filter. So when it applied this filter, so number of partition reduces, then it is started to scan the partition. So remove partition runtime which match with where condition. So it applied the where condition, then it remove the partition at the runtime. So it make the query fast, and also it is very useful. Now next is very important, AQE, which contain all the features. Like currently it comes with the Spark 3 version, Spark 3.x new versions. So adaptive query execution is something dynamically optimized query execution plan based on the runtime metrics, enabling better performance, especially in scenario where data characteristics are unpredictable. So most of the company using these features, and it is a very very good features, and it reduces a lot of hurdles, lot of work which we need to do to optimize our Spark program. So how it works? So it basically dynamically calculate the execution plan based on the data. So we don't need to worry about the broadcast join. We don't need to worry about our Spark dynamic pruning. So shuffle join. So all these things it dynamically handle based on their query plan, based on their understanding of the data. So that is a very new features, and it is used very vastly. And how can we enable this? So there is a configuration variable spark.secure.adaptive enabled equal to true. So when we make this variable as a true, so it enabled, and what it did, it do resource optimization, handling data skew, optimize join strategy. So AQ automatically decide based on the data characteristic at a runtime which join strategy is useful for our Spark program, our query. So it decide whether broadcast join work, whether sort merge join is good for here. So it applied dynamically, handling data skew. Data skew means the data unequally divided into the partition. Some partition have some large data, some partition some low data. So that data skewness also handled by the AQE. Resource optimization, so it highly optimize the resource, and all the executors codes, it's optimizedly and dynamically optimize the things based on the data partition, all these things it handle. So this is a very good features, and it is comes on Spark 3.0, so that is definitely company using this. And we can see the flow of this broadcast and AQE and broadcast. So that is the most usable in our industry, and So PySpark, yeah, Spark, we can say these two features is widely used for optimization. So Spark AQ, if you can see chart AQ overview, then it analyze the query plan, then it adjust query plan based on the details, analyzing details, then it execute the optimized plan and improve the performance, and then we can process the large data like on GBs, terabytes. And second most important is broadcast join. So broadcast join also identify the small data set and distributed that data set into all the node, that small data set distributed across all the node, and then execute join operation, improve performance, and then handling large scale data processing. So I hope this video you feel is good for you, and I think you like the channel, subscribe the channel, and please give me the comment how you like, means what you learn from this video. If you find good, then please comment on this video. Thanks, have a nice day.